Hey guys, so as we all know, statistics is a very powerful tool that we can use to help explain and understand many things. But it's always important to know how to use statistics because if you're making mistakes with it, it can lead to some very strange conclusions. So the first misconception that I'd like to tell you about, and really the most common one, is correlation does not imply causation. Why is it the most common? Because it's almost intuitive that people think that if two things happen at the same time or they somehow match up, surely they must be connected. So let's look at my favorite example using aliens. On this graph, we have the year. Over here, we have January, all the months ending in December, and two variables. The smaller one will be boating accidents, and the larger one will be ice cream consumption. So the aliens gathered all this data and they're looking at these two graphs and they're thinking, wow, why is it that when people eat ice cream, they start getting into boat accidents? That doesn't make any sense. Now, of course, for us, it's very simple. It's because it's the summer. People eat ice cream in the summer and then they go into boats and unfortunately get into accidents. But this is a very important thing to remember that just because two things happen at the same time, it doesn't mean that one can cause the other. There's usually an underlying variable causing both effects. So the next common misconception is called the average trap. What does it mean? Let's take a look. Now on this graph, we have three normal distributions, the yellow, red, and blue. And as you can see, their average, their mean is 0 for all of them. But obviously, they don't all look the same. This is a very important lesson because when you look at distributions, you always need at least two parameters to really understand what kind of data you're looking at. In our case, it's mean and variance for normal distributions, but there's many other parameters you can look at. Another good example that I like is always having to do with income distribution. How people say the GDP per capita is blah, blah, blah. Well, what does that really mean? Because not everybody makes an equal amount of money within the country. It's usually something like this, a distribution that's, they call it the 80-20 distribution, where 80% of the people will make 20% of the money, and then 20% of the people will make 80% of the money. And this isn't only true for income. This is the same also for, say, business. So an alcohol company will sell 80% of its beer to 20% of its clients, the ones who drink the most. But with these kinds of statistics, we always just say the average for someone, even though it's not a linear average. So very important to keep that in mind. Another very common mistake, and probably because most people don't even realize that there's a difference, is the difference between percent and percentage points. And what's the difference? Let's take a look. One is relative and the other is fixed. What does that mean? So let's do this example. Let's say you got an 80% on a test and your teacher says that you can retake it. And then when your friend asks you, you say, I did 10% better than the last time, than my 80. What does that mean? If you did 10% better, then your score is 88% because 10% of 80 is 88. But if you did 10 percentage points better, then your new score is 90 because you actually added plus 10 percentage points to your previous score of 80. This is a very big difference, and if now that you know it, be on the lookout because many articles and even news sources actually use the difference, but personally, I never heard it until somebody told me that there's a difference. And then you actually start realizing that you've been thinking wrong the whole time. Another thing that people tend to do is jump to conclusion based on proportions without considering the sample bias. What does that mean? Let's look at this example. So say we have a company that has 3/4 male employees and 1/4 female employees. So at first glance, we would say that, wow, this is so sexist. This company only tends to hire men. What's the problem with this? But then if we look at, say, the pool of applicants and see that the company receives 90% male resumes and 10% female resumes, then all of a sudden we see that no, they're really not discriminating. In fact, if they are discriminating, it's against men because they should have as many employees as they have applicants as far as the proportion is concerned. So it's always important to look at the sample instead of just the end result of the proportion. And unfortunately, the most relevant misconception for us today is how to properly calculate the COVID death rate. What most people do is they take total deaths and just divide by total cases, which is wrong because we want to know how people stop having coronavirus. And there's really only two ways. They either recover or unfortunately they die. So that's the proportion we want to look at. To accurately calculate the death rate, we want to divide total deaths by the total number of people who stopped having coronavirus. In this case, recovered plus died. Here we have the two percentage rates for both worldwide and the USA. And finally, how can we accurately say who actually died from COVID and who died from pre-existing conditions? Here's how we can do that. We would just need to look at the historical average of deaths for each month, say for the past 5 years, and look at the 2020 results. And that little orange spike for each month would be the exact COVID deaths. I mean, not exact, it wouldn't be down to the person, but within the range of 1 or 2% error, I think is good enough.
Want to learn more? Check out the next video. Quick reminder to subscribe to Geekly EDU.